Hello children, this is Suresh Sukarma presenting Divine Public School in the e-learning classes of the subject Mathematics, class 10th, chapter 3, pair of linear equations into variables. This is the part number 2. In the last video we have learned about the introduction of this chapter. So let us start this chapter. In this module we are going to learn that symmetrical representation of pair of linear equation into variables. After learning the geometrical representation of pair of linear equation into variable, we will have to solve the example number 1, example 2 and example number 3. So on the completion of these 3 examples, you are able to solve the first exercise of this chapter, which is 3.1. So let us see what is the geometrical representation of a pair of linear equation into variable. Geometrical representation, it means graphical method we are going to do. So not only geometrical method we have to learn, here we are going to construct the equations algebraically also. So let us see what is algebraic method and what is symmetrical method. See the symmetrical representation of pair of linear equation into variables. As you know that the geometrical, it means graphical method representation of a pair of linear equation into variables is a straight line together. We can that now can you suggest what a pair of linear equations into variables? So let us see. We look like as a symmetrically there will be 2 straight lines, both will be considered together. For this, only one of the following 3 possibilities can happen after representing the graphically. Let us see what are these possibilities can happen. So first possibility is that 2 lines will intersect at one point. It means the equations have unique solution. 2 lines intersect at one point. It means when you draw the graphically both the lines, they will intersect at one point. And this one point is called the unique solution also. Means your figure looks like this. This is the first line, it is the second line, and they are intersecting at this point. Now because of they are intersecting each other, you are getting unique solution, and because of this solution these equations are called consistent also. Now see the second possibility. For the second possibility, the 2 lines will not intersect at, it means when they will not intersect, it means both the lines are parallel. Therefore equations have no solution since they are not intersecting anywhere, so they do not produce any of the solution. They don't have solution, and the figure looks like that. This is the first line, this is the second line, and they are parallel to each other, they are not intersecting. So because of they are not intersecting, it means they have no solution. So these equations are called inconsistent also. So if the equations giving you the solution is called consistent, if the equations are not giving the solution, is called inconsistent. Now the third possibility is the two lines will be coincident. It means the equations have infinite many solutions. So the figure of this, both the lines are representing, because of this they are called consistent. Okay children, now here you can see when the equations gives you the solution, means the lines are intersecting, like in the condition first and in the third condition, so the equations are called consistent. Keep it in mind. And if the equations do not intersect each other, means the lines are parallel, so the equations are called inconsistent also. So these conditions you just keep it in your mind, because they are very useful to solve the sums of 1 marks. Okay children, now let us start the examples of your textbook. See the example number 1. This example we have learned in the last video, but there was few problems in the video. Sorry for those problems. That's why we have taken again this question in this video. Your question is, Akhila went to a fair in her village. She wanted to enjoy rides on the giant wheel and she wants to play hoopla also. The number of times she played hoopla is half of the number of the rides she had on the wheel, on the giant wheel. Okay, if each ride cost ₹3 and the game of hoopla cost ₹4, then how would you find out the number of rides she had and how many times she played hoopla? So for this, for the provided information, she spends ₹20 total. So let us find the solution of this equation. Once again, understand it easily. In this solution, first of all we have to suppose something. So it is given for the denote the number of rides on the giant wheel that Akhila had by x, means number of rides she had taken x, and the number of times she played hoopla p y. Now according to the situation, we can represent both the equations easily. So the first situation is the number of times she played hoopla, which is the 5. The number of times she played hoopla is half of the number of rides she had taken on the wheel. This means y is equals to x upon 2, means y is the half of x, When you solve this equation, you will get x minus 2y is equals to 0. And the second condition is, if each ride cost rupees 3, means she had taken total x rides and each ride cost 3 rupees, so total cost is 3x. And the game played, for each game played, rupees cost 4. So here the number of played game is 5, so the total cost is 4y. And she spent rupees 20, so 3x plus 4y is equals to 20. Here it is the x minus 2y is the first equation based on the first condition, and 3x plus 4y is equals to 20 is the second equation based on the second condition. Now we have, let us represent these equations graphically. For this, we need at least 2 solutions for each equations. We give these solutions in this table. Let us see. First equation is x minus 2y equals to 0. Equation number 1. When you solve this, means when you get the values of x and y, so here, as you know that y is equals to x upon 2, if taken x is equals to 0, you will get y is also 0. If you will take x is equals to 2, then you will get y is equals to 1. So this is the solution. So the 2 solutions of this equation is 0, 0 and 2, 1. See the second equation. 3x plus 4y is equals to 20. That is the second. Find the solution of this equation also. See the solution. In this there are 3 solutions we have taken. If x is equals to 0 you have taken, then you will get y is equals to 20 upon 4, which is 5. If y is equals to 0 you have taken, then x is equals to 20 upon 3, second solution. And if x is equals to 4, you will get y is equals to 2 according to this condition. So there are 3 solutions of this, 0, 5. Second solution is 20 upon 3 and 0. And third solution is 4 and 2. We need only 2 solutions for drawing any of the line. Okay, let us see the graph of both the lines. Here is the graph given. This is y-axis, it is x-axis. Now this is point P, which is 0, 5, and this is point 4, 2. Now for the point these two, we can draw a line. This is the line representing the second equation, 3x plus 4y is equals to 20, and this is the line which passes through the origin 0, 0 and the point 2, 1. And after drawing these 2 lines, we have, it means we are seeing that these 2 lines are intersecting at the point Q, and the coordinate of this point Q is 4, 2. It means it has unique solutions. So the value of x is 4 and the value of y is 2 satisfies both the equation. It means, as you have read, x was the number of rides that Akhila had taken on Saint wheel. It means she had 4 rides on the wheel and she played 2 times the game Hoopla. Understood, children? Now we observe that 2 linear equations representing the 2 equations two equations are intersecting at the point 4, 2. So Akhila had 4 rides on the field and she played hoopla 2 times. This is the answer of this equation. So we have represented this condition algebraically, means made the equation, and graphically also, and we find the solution by using graph also. So the children, before solving the equation, we can find the solution of the equation by graphically also. This you understand. Now see the example number 2. In this example, Romila went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9. 2 pencils and 3 erasers for ₹9, and her friend Sonali saw the new variety of the pencils and erasers. So she also bought 4 pencils and 6 erasers for the same kind of for ₹18. So represent this situation algebraically and graphically. From both the method we have to represent it. So let us see the solution of this equation based on the condition. First of all, we have to represent the equation algebraically according to the condition, afterwards the graphically of those algebraic equations. For the solution, let us suppose that the cost of 1 pencil by ₹X and the cost of 1 eraser by ₹5. Then the algebraic representation of the equation is given by the following equations. First, as the first condition was taken 2 pencil and 3 eraser for ₹9. So the cost of 1 pencil is ₹X. So the cost of 2 pencil will be 2x, and cost of 1 eraser is ₹Y. So the cost of 3 eraser will be 3y. So the total cost 2x plus 3y, which is equals to 9, equation number 1. Now second condition is, as her friend taken 4 pencil and 6 eraser, means 4x plus 6y for the ₹18, that 4x plus 6y is equals to 18 is equation number 2. Now to obtain the equivalent symmetric representation, we find at least 2 points on the lines representing each equation. So that means we find 2 solutions for each of the equations. These solutions are given by below in the table. So the students, to draw the graph, it means to draw the graph of each of the equations, we have to find out 2 solutions for each of the equations separately. So for first equation we have to find 2 solutions, and for second equation we have to find 2 solutions. So as you know that for drawing a line 2 points are necessary, so that we have to draw it. Okay, let us see the children. For the first equation is 2x plus 3y equals to 9. It is equation number 1. Let us find out the 3 solution of this equation. So x and y. If x is 0, you have taken, so you will get y is equals to 3, and if x is equals to 4.5, then y is equals to 0, you will get it. So there are two solutions. First solution is 0, 3, the value of x and the value of y. Second solution is 4.5 and 0. Similarly, for the second equation, which was 4x plus 6y is equals to 18, you have to find two solutions for this also. If x is equals to 0, you will get y is equals to 3. If x is equals to 3, you will get y is equals to 1. So two solutions we have taken from both the equation. So first solution of this is 0, 3, and second solution is 3, 1. Let us represent these points on the graph. See what will happen. See, this is the graph. When you draw 0, 3, 0, 3 is this point, and if you draw 4.5 and 0 is this point. So after taking these 2 points, we have to draw this line, and the equation of this line is 2x plus 3y is equals to 9. Okay, now see the second equation. You have taken 0, 3 and second point is 3, 1. When you draw the line of this equation 4x plus 6y is equals to 18, so you will see that, you will observe that both the lines are intersecting each other, or you can say both the lines are overlapping on each other. Therefore, the condition is saying it means they have infinitely many solutions. It means they are consistent, the equations are consistent because they are giving the solutions. So when we plot these points in the graph paper, the lines, we find that both the lines are coincident. This is so because both the equations are equivalent. It means one can be derived from the other. Okay students, now see the example number 3. In this example, the question is, two rails are represented by the equations, and the equations are given: x plus 2y minus 4 equals to 0 and 2x plus 4y minus 12 equals to 0. Given that, represent this situation geometrically, because algebraically it is given. Equations are given, so no need to find the algebraic representation. We are going to represent these equations graphically or symmetrically. So to find the figure of these equations, we need to find at least two solutions of each equations. So in the solution, we are going to find two solutions of each of the equations. That is, first equation is x plus 2y minus 4 equals to 0. Equation number 1. Find the solutions with the help of the table. If x is equals to 0, you will get y is equals to 2. If x is equals to 4, we will get y is equals to 0. So there are two solutions of this. Point are 0, 2 and point as 4, 0. Now see the equation number 2. 2x plus 4y minus 12 equals to 0. When you take x is equals to 0 in this, you will get y is equals to 3. If you take x is equals to 6, you will get y is equals to 0. So the two solutions of these equations are 0, 3 and 6, 0. Now see the graph of this equation. To represent the equations graphically, we plot these points R02 as 40 to get the line first RS, and the points P03 and Q60 to get the line PQ. So see the graph of this one. So when we plot, when we take this RS, you will get the line. This is RS means 2002 and 40. This is the equation of the this is the line of the equation x plus 2y minus 4 equals to 0, and this is the 2x plus 4y minus 12 equals to 0. So you will observe that both the lines are parallel to each other. Okay, from the figure we are seeing that the lines are parallel to each other. It means they do not have any of the solution. So the lines, so the equations are called inconsistent. You just see it. Afterward, we observe in the figure that the lines do not intersect each other at any point, therefore they are parallel to each other. So the children, we got the three conditions graphically, algebraically. We have seen several situations which can be represented by a pair of linear equations. We have seen their algebraic and symmetric representations. In the next few sessions, we will discuss how these representation can be used to look for the solutions of the pair of linear equations as we discussed. So the solutions already we have discussed, but from the questions you can understand the solutions also. So the children, see the videos carefully and understand the concept of the pair of linear equations, those three conditions. For first, unique solutions means the lines are intersecting at one point, and the second, the lines are intersecting at infinitely many solutions, and these two conditions are called consistent also. And third condition is when the lines do not intersect anywhere, it means the equations are called inconsistent. So thank you.